Okay, so we talked about the exponential growth versus decay in word problems, but then we're going to talk about what this looks like on a graph. So we're going to throw some new vocabulary at you and connect it to what we've been doing the last couple of days. We're talking about features of exponential functions. So we have a new equation. It's not like slope-intercept. It's not like quadratics. This is exponential, where we have y equals a times b raised to the power of x. A, you should know from the last couple of days, represents that initial amount, but on a graph, it represents the y-intercept. And the b value is a lot like the slope in a way, not necessarily the same, but the b value tells you whether it's growth or decay. If the b value is greater than 1, then it's going to be growth. If b is less than 1, then it's going to be decay. Now, where that b value came from, if you remember, when we talked about increase versus decrease or growth or decay, the parentheses in the equation was like 1 plus the r versus 1 minus the r. That's where the b value comes from, is what did I add to 1 or what did I subtract from 1. So that's that connection. Now, what the graphs look like, so exponential is a very, very sharp increase or very sharp decrease. So you're going to see growth in two different ways. You're going to see it where it looks like it's flat, 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 and then it shoots up. Or you're going to see it where it shoots up and then flattens towards the x-axis. So you could see it either way. Decay would be when it shoots down and then flattens out towards the x-axis. And then the other type you might see is whenever it starts out flat underneath the x-axis and then shoots down. So decay, growth versus decay. Growth means increase, so it looks like it's going upwards. Decay means it's going down. Similar to slope in a way. Now, the new vocabulary word is something called the asymptote. So if you remember when we did quadratics, we learned something called axis of symmetry. This was that imaginary vertical line that cut the parabola in half. And remember, that was always x equals some number. Whereas asymptote is the opposite of that. It's not a vertical line, it's a horizontal line. And it's not x equals, it's always going to be y equals a number. So let me show you some examples because I might have lost you, okay? So number one, just based off the graph, is that growth or is that decay? Well, it starts out flat and then shoots up, so that's growth. Y-intercept, where is it crossing the y-axis? That would be 0, 4 as a coordinate. The domain, 99% of the time, how far left does it go? How far right does it go? It goes forever and ever, so that's all reals. And the range, we'll talk about here in a second because I want to connect it to the asymptote, okay? The asymptote, remember, is that imaginary horizontal line. Do you see where the graph starts to flatten like that? So where it starts to flatten is your asymptote. There's an imaginary boundary line that this graph actually never touches, even though it looks like it is. So you see the line that I drew? Well, what's the equation of that line? It is y equals 0, because that's where it starts to flatten. Now, the range is the trickiest part, because a lot of people assume that this, where it starts to flatten, is actually touching 0, but if we zoomed in a million times, no matter how much we zoomed in, it actually never touches the 0, the y, or the x-axis. So it's what we say, so if notice the graph is above 0, so the range is y is greater than 0. Not greater than or equal to, just greater than, because it's above 0. If I lost you, number 2, okay? Growth or decay, well, this time it shoots down and then flattens, so we call that decay because it is going down. The y-intercept looks like it's a decimal, but it's between 4 and 6, so it's 0, 5. The domain, again, 99% of the time is all reals. The range we'll talk about because it's connected to the asymptote. Where it starts to flatten is y equals 0, okay? And most of the time it's y equals 0. We'll talk about where it's not, okay? And then the range is above 0, so y is greater than 0. Not equal to, because even though it looks like it touches 0, it doesn't. It's just one of those that's kind of deceptive. Number 3, growth or decay. So this is one that throws people off, but notice that it shoots up and then flattens, so that is growth. The y-intercept is 0, negative 1. I know the numbers are a little hard to see. The domain, 99% of the time, is all reals. Now the range this time. So the asymptote is also y equals 0. But notice that this time it's below 0. So this is y is less than 0. Not less than or equal to, just less than. Number 4, growth or decay. So it starts out flat and then shoots down. So it's decay. The y-intercept is 0, negative 1. and then the domain is all reals 99% of the time. The range is connected to the asymptote. So the asymptote is y equals 0 because it's flattened there. And then notice it's below 0, so that would be y is less than 0. Number 5, growth, because it's increasing. Y-intercept looks like a decimal, but notice that they're counting by 2s. Even though I see 4s, 2 boxes is 4, 1 box is 2. So if this jumps by 2s, 0 between 0 and 2 is -1. So 0, -1. The domain, of course, is all reals. The range is connected to the asymptote, but notice it's not flattening at 0 anymore. It's flattening at -2. So y equals -2 in this case. The range is above -2, so y is greater than -2. And number 6, this is where the domain is not all reals all the time. So if I look at number 6, it is growth because it's going up. The y-intercept is 0, 20 this time. The domain is not all reals because notice it stops at 0 here. It doesn't go to the left of 0. So this is x is greater than or equal to 0 because it's to the right of 0. The range is like the asymptote. See, it starts to flatten at 20. So the asymptote is y equals 20. Whereas the graph goes above 20, so y is greater than 20, just like before, okay? Now, what if I took away the graph completely? So I'm going to show you how to do this in the calculator, but you have to also be able to interpret the equations without a graph and without a calculator. Y equals a times b raised to the power of x. Remember, a is your y-intercept. This is that starting value. The b is your rate. That's where you determine, is it growth or is it decay? Is it going up? Is it going down? Okay. And how I know which one's which is if it's less than 1, it's decay. If it's greater than 1, it's growth. Okay, so just keep that in mind. Now, the part that's different today, or with these questions, is you're going to see a number that's off to the side after the exponent x, okay? What this does, if you remember in quadratics, it's like that transformation part where we did like vertical stretch, vertical compress, up, down, left, right. This is equivalent to the d value, and the d value on those just told you whether it went up or down. So we'll talk about that. Number 7. So growth or decay. How do I know? I look at the number next to the x. It's 4. Since it's greater than 1, that's growth, okay? Now the y-intercept is the number in front of 4. So the y-intercept is 0, 5. The domain, of course, we just assume is all reals. And then the range, because let's go to the asymptote here. 99% of the time, the asymptote is going to be y equals 0, unless there's some sort of shift. Well, this doesn't have a number after x, so we're going to assume that y equals 0. Now, because I know it's growth, it's y equals 0, it's going to be pointed up, the y-intercept is 0, 5, I know that the range is going to be y is greater than 0. I know it's not going to be pointed down, and we're actually not going to see any like that today. But where I can show you how to do all of this with a calculator is you go to y equals in your calculator, you type in the equation, okay, so 5 parentheses 4 raised to the power of x, and you hit graph. And you can see the graph do what we just talked about. It's growth, it's going up. The y-intercept is hard to see, but it's 0, 5. The domain is all reals. The range, it starts to flatten, which you can't see the continued flatten, but it starts to flatten at 0, and it's above 0. See the connection? So let's try without a calculator. Here it's growth. How do I know? The number next to x is greater than 1. The y-intercept is 7, but because of the shift of 5 up, because it's positive 5, it's no longer going to cross at y at 7, it's going to cross at 12. At 12, so it's 0, 12 is the y-intercept. So that's the crazy part about this one. The y-intercept should be 7, but because of the plus 5, it moves it up 5, so that means it crosses at 0, 12. So that also is going to affect the asymptote here in a second. The domain, of course, we assume is all reals. The range is going to be different because of the asymptote. The asymptote should always be y equals 0, but because of the shift in 5, the asymptote is y equals 5. Okay, because it should be 0, but it shifted up 5, so y equals 5. Now, because of that, the range is going to be affected too. So the range has to do with the asymptote, which means it's going to be greater than 5. And again, I can type all this in the calculator to check it. Number 9, growth or decay. I know it's decay because the number next to x is less than 1. Now this is a tricky part. What is the y-intercept? Well, think about it. What is the number in front of any variable when there's not one? Well, there's an invisible 1 there. So the y-intercept is 0, 1. Weird, right? The domain is all reals, we assume. The range, or the asymptote, because there's not a shift in here, the asymptote we're going to assume is y equals 0. And then the range, we assume is y is greater than 0, because it doesn't have any kind of negative involved. So I know it's not pointing down necessarily, okay? Number 10. So growth or decay, the number next to x is 2, which is greater than 1, so I know it's growth. Now the y-intercept should be this number in front of 2, and since there's not 1, we assume it's a 1. Now the y-intercept should be 0, 1, but because of the shift up in 5, the y-intercept is now 0, 6, because 1 plus 6. The domain is all reals. The range is connected to the asymptote. Now again, the asymptote should be y equals 0, but because of the shift up in 5, it's y equals 5. And then the range is connected to the asymptote, and we assume it's y is greater than 5, unless it has some sort of negative, which it doesn't. Number 11, just like number 9, the number next to x is your growth or decay, so that's growth because it's greater than 1. Now there's technically a number in front of the 3, which is an invisible 1, which makes the y-intercept 1. It does not have to shift, it does not have a shift up or down, so the y-intercept is 0, 1. The domain is all reals unless otherwise specified, and the asymptote, because there's not a shift up or down, we assume the asymptote is 0, always. And then because the asymptote is 0, the range is greater than 0. There is no negative, which implies a downwards decline, so there it is, okay? Number 12, the 1/2 next to x shows decay because it's less than 1. The y-intercept is the number in front of 1/2, which is an invisible 1, which is 0, 1. And the shift down actually moves the 0, 1 y-intercept to 0, 0. The domain is all reals. The asymptote should be y equals 0, but because the shift down in 1, it's y equals negative 1. And then the range is greater than negative 1 because of the asymptote got shifted. A lot of information I know, but we'll talk about it again.